Today, we have a presentation about the Haw River Assembly's water quality monitoring program and its adoption of a new data management and visualization platform. So my name is Lucas Stevens. I'm a policy associate at the Nicholas Institute at Duke, and I'll be your host for our webinar today. Over the past year, the Haw River Assembly has partnered with the Commons to integrate its water quality monitoring programs within Water Reporter. And Water Reporter is a digital platform for community science data management and data collection and data visualization. So today we'll hear from Emily Sutton, the Haw Riverkeeper, and she'll present on all of the various environmental issues that are facing the river and how the data that she collects helps all river users to better understand those issues and identify solutions. So I'll hand it over to Emily in just a minute, but first I want to go over some housekeeping details. So we are recording the webinar today, and the recording and the presentation slides will be available on our website at internetofwater.org under our events page soon after the webinar ends today. So if you came in late, or if you have to leave early, or if you missed part of the webinar, don't worry, you can catch it on our website, and you can share it with other people in your network as well. After the webinar today, after the presentation, we'll have 15 or 20 minutes or so for question and answers. So feel free at any time, if a question pops into your head, to put it in the Q&A box, and I'll read them out following the presentation and moderate. If you have any administrative issues, like the video cuts out or the audio cuts out, feel free to put these in the chat box, and we'll try to get those fixed during the presentation. All right, well, thank you everyone for coming and welcome. I'm going to go ahead and stop sharing and hand it over to Emily for a presentation.
Hey everyone, I'm Emily Sutton. I'm going to get my screen going here real quick. Okay. So can you all see that? We're good? Okay. So I'm so glad that you guys are joining this webinar today. I'm really thankful that we got to work with Internet of Water and Water Reporter to build this visual tool. Haw River Assembly has been around for a long time. This is our 40th year anniversary, actually. And so we have so much data about the health of our streams and macroinvertebrate trends. And we really just needed a way to get all of this data out of Excel spreadsheets and access databases into a tool that people could use and visualize. So this has been a really great project for us, and I'm excited to tell you about it. So first of all, who are we? I know a lot of the people on this webinar today are state agency folks, and for us as a nonprofit, we're really focused on the advocacy work. So we are able to work with community members, build comment letters, and give talking points to impacted communities for any potential pollution threat. For my job as the Riverkeeper, I'm doing a lot of water quality monitoring below suspected pollution issues. And I'm collecting all of this information to really determine if there is a problem, what is the source of the problem, and how do we solve that. But our organization also does a lot of other things. So I also work with a lot of the North Carolina Riverkeepers. There's 15 of us in North Carolina on state policy work. So we do a lot of lobbying work, direct and indirect lobbying, and use all of this information about our watersheds to move forward common sense policy. We also do a lot of education and outreach. So we've got school programs, we've got field trips that our other staff members take care of. So we really focus on the big picture of water quality in the Haw River watershed. So just so you guys have a sense of place, I'm a visual person and I love maps. So this is our watershed. It stretches over 8 counties in North Carolina, in the Triad area and the Piedmont into the Triangle. And that big red dragon looking thing at the bottom of this map here is Jordan Lake. So Jordan Lake is part of the Haw River watershed, and a big chunk of Durham and Chapel Hill that flow into Jordan Lake. So we have a lot of opportunities for collaboration and partnerships because of that advocacy role and that knowledge that we have of our watershed and the communities that live here. So when I first started in this work, I was able to really get a sense of what the issues were based on the concerns that community members have. And so we are a direct resource for impacted communities, whether they're fighting a pipeline or a huge development or an asphalt plant. We are directly connected to the people who are impacted. So we also do a bunch of grassroots organizing. The picture that I showed a couple slides before, we knocked on doors in Alamance and Rockingham County and held meetings in churches and people's barns and let people know about a pipeline that was proposed. And then we had so many people turn up for a public hearing and pack every single meeting of town boards and county commissioners. And we're really able to encourage people and give them the tools that they need to be the voices for their community and engage in these public processes. So a lot of the other work that we do, we're able to litigate. We work with Southern Environmental Law Center on a lot of cases. Right now, we're currently in 5 different cases with them. And so that is all informed by investigation, monitoring, and community input. So those partnerships that I mentioned earlier, we have a lot of academic research partnerships because of those connections to the ground in the communities. And so right now we're getting requests from researchers who are looking for impacts from biosolids or community members that will let us access their wells to test for antibiotics. And we are really able to connect the right people with the right researchers because we know our communities and we know where these impacts are. We've also worked with emergency management folks on a lot of these things for where flooding happens, or if there's a paddle access that is really dangerous, or a log that's a strainer that could be really dangerous for kayakers. So we have been able to use our knowledge of our watershed and the data that we collect to really help all of these other departments. So some of you may already know about the issues in the Haw, so I won't spend too much time here, but one of the big issues that we work on right now is this issue of forever chemicals. PFAS and 1,4-dioxane are 2 different categories of those forever chemicals, and they're called forever chemicals because they're not traditionally moved in any drinking water treatment, and they never break down. They're meant, chemically built to never break down. Those are your things like Teflon, fire resistant, stain resistant, water resistant, those kind of coatings and chemicals that are supposed to last forever. So they last forever in our bodies as well. And they've been tied to serious health impacts like liver damage, high cholesterol, hypertension, low birth weight. So this has been tied to direct dischargers that use wastewater treatment plants in our watershed. So we've been able to look at pre-treatment programs and really parcel out which one of those industrial users within the systems are contributing to those loads of toxic chemicals. Industrial animal agriculture, this is not as big of a deal in our watershed as it is in other parts of the state, but we have a lot of poultry operations. And the issue with poultry is that there will be massive piles of poultry litter that are stored outdoors, exposed to wind and rain, and often next to streams. And so that wind and rain will carry all of those bacteria and ammonium and nutrient loads into our streams. This is also an urbanizing watershed. It's between the Triad region in Greensboro and the Triangle in Durham and Chapel Hill in Chatham County. So we have a lot of sedimentation issues and buffer violations and trash. So especially with the trash, we're able to do a lot of really proactive projects like installing floating litter traps, and we've had live staking events to rebuild buffers that have been violated and have been destroyed. And then we also have a lot of sanitary sewer overflows because a lot of these towns have failing infrastructure. They have low budgets and they're old towns. And so the infrastructure has failed, or it's been combined with stormwater. So every time there's a significant rain event, you can count on sewer overflows from 3 specific manholes. And that leads to enormous levels of bacteria, E. coli, and fecal in our streams and in our river. So I wanted to go through the specific issues because we collect data to inform all of our advocacy on those issues, but all data is not created equal. So we're using our numbers to really inform our advocacy and sometimes our litigation and what we're moving forward with. And so we can't use citizen science data for all of those things, right? So we do have a really robust citizen science monitoring programs. So right now we have about 50 active teams throughout the watershed that are a part of our program called River Watch. And those teams go out 4 times a year, once seasonally, to the same spot on their same creek, and they monitor for pH and macroinvertebrate health and look at visual parameters. Does the stream have access to a floodplain? Is the buffer caving away? So those that information that we can't know unless we're there with our eyes on the stream. And we're a small organization. We can only be so many places at once. So that's a really incredible program for us. And it's been around since the beginning of our organization. So for some of these streams, we have so much information about the trends and the health of that stream or section of stream over time. Another program that we have is our Muddy Water Watch, and that has allowed us to teach community members what a sediment violation looks like. So we're not just taking pictures of a muddy puddle, we're teaching them to take pictures of downed silt fences or sediment leaving a job site, or things that are really telling to a sediment and erosion control staff member in the county. And this has also, being able to visualize that information spatially, we're able to see if the county has been overwhelmed by sediment issues from the same type of development or the same development company. So that's been a really great way to visualize and inform how we focus our work on sedimentation. The other one is litter surveys, and I'm going to talk a little bit more about this later, but we not only collect trash from our litter traps or do cleanups along the banks, but occasionally we'll also do a survey about what kind of trash we're finding. And so like a big portion of that trash, is it styrofoam? Is it plastic bags? Is it single-use plastics from restaurants? And so we can use that information to incentivize businesses to eliminate their single-use plastic waste. So those are our volunteer citizen science efforts. And so the rest of these, we have very standardized sampling protocols because we submit this information to the state, or we submit this information to a law firm to do further investigation with third-party labs. And this information, I'm not going to spend too much time on this, but this information, a lot of it is already on our Internet of Water database, so I'll get back to a lot of these. So here's one specific example, our swim guide program. This is a really great program that I've loved that we've been able to partner with. Swim Guide is based out of Ontario, Canada. They work with a bunch of different river keepers all over the globe. So this program has allowed us to collect E. coli samples, which are very easy and cost effective for us to process in our own lab. We have our own IDEX processing incubator in our offices. And so we're able to collect E. coli samples and process the samples ourselves. So we can look at where these beaches are, where these popular swimming accesses are, and see if it's safe. Are the bacteria levels below EPA's beach action value? And we collect the samples on Thursday and publish the data on Friday. So it's not a perfect system. I wish that we had an instant way to know if the E. coli levels were high or low, so we could present that data immediately. But we've had a lot of engagement with the public on this. And so much so that we've been able to use this information to get our members to help us advocate for a transition for the state standard to be E. coli rather than fecal. And that was a big advocacy push that we had in the triennial review period just a few months ago. We're also able to use this information for advocacy to push for these state water quality standards to be for all waters and not just Class B primary recreation waters, because I don't know about you guys, but I'm not looking at the maps to see where Class B waters are before I'm jumping in a river. So a lot of our accesses are not Class B. And this also encourages the public to find new places to explore and take their families to go swimming. I can't tell you how many times I've gotten people that didn't even know that you could swim at beaches in Jordan Lake, or they just for the first time explored this swimming access on the Haw. So it's a really good way to get people outside in the summer. This is another use that we've really enjoyed with the visualization of a lot of this data. When we were first looking into PFAS sources, we worked with NC State and EPA and Duke University to sample upstream and downstream of any potential sources that we could think of. We had so many potential sources. And it was really isolated within these three cities, Burlington, Greensboro, and Reidsville. So once we identified that those cities were responsible for the highest loads, we were able to look into their pretreatment systems and look at their significant industrial users. And that has gotten us only so far, because another piece of this is that those cities are also applying land applied biosolids on fields all over the watershed. So we began to track where those sludge applications were and monitor surface water streams adjacent to those fields. So with this map that we've been able to have, we can prioritize what locations pose the greatest risk for public health impacts, whether that's the direct drinking water supply in Pittsboro, which is the only town in our watershed that pulls directly from the Haw, or if we need to be concerned about private wells. And so we're just really starting a lot of the research on the private wells to understand what the risks are there, but without being able to visualize that data, it would have been a lot harder to figure out what wells to prioritize. So these are the questions that we've been able to ask and address. I won't say that we've answered them all, but because of this tool, being able to visualize our data. So looking at trends where we have repeat E. coli spikes, and is it all from sanitary sewer overflows, or is it from animal agriculture, or is it right next to a park that has a bunch of dogs? All of those things could be contributing factors to the reasons that we have these spikes in E. coli. The same with nutrient levels. Is it municipal, stormwater, or agriculture? How do we prioritize holding polluters accountable? Where's the biggest risk for the public? And then another great piece of this is we're able to look at cumulative impacts for a community. So one example of this is we had a community in Caswell County that an asphalt plant was proposed in their community. And an asphalt plant has specific health issues for air quality, but this particular community was also surrounded by poultry operations, was surrounded by a bunch of different industrial facilities. And so looking at all of these contributing factors, it really informed what the cumulative risks of adding another polluting industry to this small community would do. And this is for our volunteer work. Not only are we able to look at the trends, but we can, when people reach out to us and want to get involved, we can point them to this map and say, this is where we have gaps. This is where we need more information, or this is where we have repeat sediment violations and we need to document more frequently. Or these are places that we've done litter surveys, but we always need a cleanup team there. And so this has been a really good tool for us to engage the public in a way that is more than just, you know, comment letter writing, which is so important to me, but people want to be in the stream. Okay, so now I will show this website real quick. Okay, can you all still see this Health of the Haw? Or are you still seeing my presentation?
Yeah, we can see it.
Okay, great. So this is the website that we worked on with Water Reporter and Internet of Water. So this is the homepage, and you can scroll down to see all of the locations of our data points throughout the Haw. So these different colors are for different programs. So our orange dots here are our swim guide program. Our purple dots here are Riverwatch data points. And these blue dots are around poultry operations for nutrients and ammonia levels. So I have one pulled up here. This is one of our swimming accesses. So you can click on a data point and really see all of the data that we've collected. Now, these are collected in the summertime, so obviously there hasn't been one collected since September, but we're able to look at the pH, the dissolved oxygen, all of these parameters that we collect, and whether or not it passed that E. coli level. And so if you're looking at this swimming access and you're curious, or it has really good health every time consistently, and you're curious, you may want to join this Riverwatch team. And so we're able to look at how these points are related. So yeah, this has been a really great program for us, and you can see all of these different points along the watershed. This also has a way to download the data that we collect. Oh, sorry, zoomed out in the wrong spot. So if you go up to this part, you can access all the raw data. So we'll have that to share. And then this is information about the parameters that we've collected and why. And we also have all of our SOP and quality assurance protocol on here as well. And that is all the presentation that I have. So I'll stop sharing, and I'd love to hear any questions.
All right, great. Thanks so much, Emily.
Yeah.
So we had one question come up while you were showing the app. And the question is, was it built using R Shiny? And that might be more of a question for the developer team at the Commons, led by John Dawes, who can maybe put it in the chat if he is here. But
yeah, he's on the list, Lucas.
yeah,
I don't know the answer to that question. I leaned very heavily on John for all the development stuff.
Yeah, so check out the chat for the answer to that question. And maybe John will be able to stick it in there for us. So I have a question about sort of your relationship. You talked a lot about collecting data and sending it to the state or sending it to the public. And you were talking, you're very conversant in sort of the regulatory structure of the Class B waters or whatever it might be. Can you talk a little bit about how sort of you have relationships with the public and with the state, and you sort of are an intermediary between the two, and how like data collection sort of facilitates that?
Yeah, that's a great question. I guess for the public, we can collect all of these parameters and tell a story about the health of our waterways, and hand that information to the public. And my job is to make sure that it makes sense and it is not a bunch of jargon and data points that don't mean anything to the public. But the part about submitting data to the state, we do that a lot, but unfortunately there's not a lot of state standards for water quality on a lot of these parameters. I mentioned that North Carolina doesn't have an E. coli standard. We're one of 4 states that still use fecal bacteria, and that transition is hopefully happening soon. We didn't get it in this triennial review period, but I won't go into all of the policy pieces right now. So we also don't have numeric standards for nitrogen and phosphorus. We use chlorophyll A. We don't test for that. We don't have the capacity to test for that. Microplastics, we don't have standards for microplastics. So like we can only submit data to the state where there is a standard. And our Riverwatch data is a little bit different because that is macroinvertebrate data, and streams may be impaired on the impaired waterways list for poor macroinvertebrate health. But our citizen science data on its own is not used for regulatory action, but it will be used to flag a regulatory investigation. So in that sense, like our data that we collect is able to tell a story about water quality health, but for the state to take any regulatory action or enforcement, there has to be a standard in place for one, and most of the time they have to do their own investigation in-house to have any enforcement.
Right. Okay, and so we got an answer to the first question. So John says that the app is not built in Arshiny, that they use the Angular framework, but there is also a fully open API that can be used for Arshiny applications. So I hope that answers that first question about the what language the app is built in. All right, Emily, are you tracking the sort of who is downloading the data and who is using it? And do you have a sense of who is accessing the data now that it's up on this new site and open for the public?
I haven't. That's a tool that we can look at who's accessing the information, but I upload new information as we get it, and then anyone can download it.
Okay. And so my other question is about, so you said you have a number of cases ongoing with SELC, that's the Southern Environmental Law Center, is that right?
Yes.
And so can you talk a little bit about how, so is the data that you collect, can that be used in those law cases? Is there a certain high bar for methodology or for data standards that is set in court cases, Or, if your data ends up in academic publications, can those be cited in court cases, or what's the sort of legal framework there?
So if we are a party to the lawsuit, we cannot collect the data ourselves. But what we do is we build the case to then hire a third-party lab, because it's expensive to do those sampling analysis at commercial laboratories. So what we'll do is work with academic labs I'll collect the information. NC State or Duke University will process the samples for us at a low cost, and we'll really understand the full picture and where the problem is happening. And so by the time that we are ready to move forward with a case and hire that commercial lab, we know exactly where we need to be monitoring to tell the whole story.
Great. And then a question about the PFAS. So my knowledge of PFAS is limited, but I do know that there are lots of different types of PFAS, right? There are different like analytes or whatever. And that, like data standards for these different types of analytes and sort of reporting requirements and all this kind of stuff have yet to be set. So how do you go about figuring out how to test for these things, how to report these things when there isn't, sort of a standard framework for that?
Well, there are approved methods for the analysis. And so for the sample collection, we follow the protocol that the lab sets, because the lab is processing that under their approved method, which falls under their standard operating procedure and quality assurance plan. And so we just do what they tell us to do as far as sample collection. And there are one issue with that, though, is that PFOA and PFAS, those two legacy compounds, the long 8-chain PFAS compounds, they've been voluntarily removed from a lot of production in the US anyway, but they've been replaced by all of these shorter chain chemicals. And so that's when you get this, people call it a game of whack-a-mole. You regulate one or two, and then all of these others come up in their place to replace it. So the problem with sampling is that the methods are only developed for specific PFAS compounds, and we don't know what we don't know. And so right now, the current methods, I think they test for about 29 PFAS compounds, but there are tens of thousands of these out there, and they're precursors to those compounds. And so we're really just trying to capture as much information as we can and hoping that those 29 compounds are the ones that are the problem for us.
Great, thanks. And so you've worked with the researchers at UNC and Duke to identify the sources?
NC State and Duke
NC State.
University. Mm-hmm.
Great. Okay, so any questions from the audience, just put them in the Q&A box and I will read them out. Emily is happy to answer them. So Emily, when you started, you talked about like the system that you had before Water Reporter was with Excel spreadsheets and Microsoft Access databases, right? So can you talk a little bit about sort of the common problems you might have had and how a reporter has sort of, helped with data management in that sense?
Yeah, our Access database was my worst nightmare. So it felt like all of our data was trapped in this database that I didn't know how to use. And, Access has so many updates, and then I had an older version and the database was in a newer version or vice versa. And so it was really daunting to figure out how we're going to be able to use all of this information in a meaningful way. And then when we transitioned to Excel, we still had, at least we could access it, but we still had a lot of issues with how to make it into a visualization that meant something to people. And so we submit our data annually to Department of Water Resources, at least for our Riverwatch information. We submit that to Department of Water Resources, and it's used for the integrated water quality report. So it doesn't set the impaired waterways report, but it is kind of the citizen science version of investigation, tracking any red flags. So once that was in Excel, we were able to do that, but still, now that we've got a more integrated tool that has all of our parameters and our standard operating procedure and a map to show where all of these pieces are, we can get a clearer picture of what is influencing the data.
Great. All right, so we've got a couple of audience questions. Does the dashboard display your data only? Or is it able to combine your data with data collected by the state or EPA or USGS?
We could add any other parameter, like any other sources of data. Right now, we've only put in Haw River Assembly's data. And that's really just to show what information we're able to collect and what information that we have. But yeah, it's possible to integrate USGS data or any other data.
And why might you do that, for example, with USGS data? For does like the flow rate matter for certain parameters, or
for certain parameters, definitely, like dissolved oxygen. And one thing that we've looked at with especially the PFAS ammonium fordoxane in biosolids is, on one hand, you may have a very diluted stream if you're monitoring for PFAS below a wastewater treatment plant outfall. So if I want to understand the problem, then I'm not going to go sample that outfall on a flood event because it's going to be mostly stormwater. I'm not going to get the high levels of PFAS that we know are being discharged there. But on the other side of that, if I know that biosolids from those same wastewater treatment plants are being land applied on a field next to a stream, I may only catch that runoff after a rain event. And so factors like that definitely influence certain parameters. There are times when the Haw is, as high as 80% effluent driven in times of drought. And so that, if we want to really understand concentration of these toxins, we want to be able to visualize what the worst case scenario could be, so we can be the most protective.
All right, great. And then we got another question. So can you, this is asking for a little bit more demonstration. Can you maybe share your screen again and show how to sort of get to the map and explore it a little bit more? So one of the audience members is having some trouble accessing it from the web page.
Sure. So I should be sharing my screen. Can you see the health of the Haw?
Yeah.
Yeah, okay, great. So this is just healthofthehaw.org, and let me go back to the homepage. So you can also access this from our website, hawriver.org, and it's under water quality monitoring in the About the River tab. So if you can't remember Health of the Haw, it's also at hawriver.org. So this is the homepage, and here we're able to look at this map. I'm just scrolling down. Sorry, my computer is a little slow. Here we go. So if I wanted to show the map details, these are all of the different points. So I could just eliminate Kflow sampling and Riverwatch and just look at our swim guide information. Here's one of my favorite beaches on Jordan Lake. And then this is all of our, so all of these measurements are taken with OYSI YSI meter. And so we're collecting that information every time to see, what could be influencing E. coli levels.
All right, great. So that's all on the homepage.
It is. You just have to scroll down.
And then the data is all available too, right? You can download
it. Is. Yeah. And so this is information about what those parameters mean, like why conductivity matters and what could influence that. And then let's see if I keep going down here. This is where you can access the data at the top.
All right, great. Okay. Can you tell us a little bit more about the Kflow sampling? So how do you find out where the facilities are, and how do you, so the landowners around, do they let you sample the streams on their land, or how do you sample upstream and downstream from those sorts of locations, and how do you design a study like that?
Those are all great questions. We're very careful to not trespass. And so all of our sampling accesses are, well, at least for the Kflow work, are all at public bridges or Department of Transportation right-of-ways. And a lot of the times, I can see the poultry operation right up the street. And so I will go out to these facilities where I know there has been a poultry litter pile that I've documented with aerial monitoring, and we'll be able to get into that stream where we have public access and sample for E. coli, fecal, and nutrients. And then all of those YSI parameters as well.
Okay. Okay, and then we just
and we're also including an antibiotic study this year, where we've been able to work with Dr. Austin Gray out of Virginia Tech to understand antibiotic loads that could be coming from poultry litter.
So the antibiotics, they're fed to the chickens presumably, and then it ends up in the litter. Yeah.
Right. Mm-hmm.
Okay, so we got a comment saying that it would be very useful to connect these sites with GeoConnects, where each site has its own discoverable landing page. So yes, so that is sort of the Internet of Water component of this. And the team at the Commons is working with the Internet of Water to develop these sorts of discoverable landing pages. And then, yes, and John has chimed in, yes, the landing pages are accessible through the Water Reporter API, and then will be exposed through GeoConnects in the coming weeks. So that will enable sort of a very easy search capability, so that the sites can be found very easily online. So for example, if you're looking for water quality, monitoring sites in the Haw River, it should be very easy to find online through the sort of structured metadata that GeoConnects will put online. So that was a little sidebar conversation going on. Okay, well, I don't see any more questions coming in from the audience. So we're going to go ahead and send out a poll to the audience members, just asking how we did today. And I want to thank you, Emily, for your presentation today. Is there anything else that you would like to tell the audience? Any parting words?
I guess, if you are in North Carolina or not, you should find your Riverkeeper. There's so many of us, and we love that we are able to do this work and hope that it can be used in a meaningful way. So if I'm your Riverkeeper, you have my contact information. If I'm not, there's probably another really wonderful Riverkeeper that would love to collaborate with you.
All right, well, thank you again, Emily. And thank you for everyone for attending.